Okay, in this video we're going to talk about an application of when to use radicals in real life. And this particular application is called the distance formula. Now this is a very useful formula, and it's one of the what I call a bridge between algebra and geometry, because this distance formula is used a lot in geometry, especially when you're trying to find triangles or distances of on a side of a triangle, that sort of thing, or just really any odd-shaped polygon. Now let me show you how this works. So the formula itself is that the distance between 2 points is equal to the square root of the difference between the two x's and the coordinates of those 2 points squared, plus the difference between the two y's of those same 2 points, again quantity squared. Now what does that mean exactly? Let's just see an example of that. Now over here I have a coordinate plane, and let's just pick out 3 points. Okay, I'm going to pick out 3 simple points. Let's just go with 0, 0. Let's go with this point here, which is 10 along the x, 0 along the y. And let's go with this point up here, which is 0 along the x, and then 10 along the y, right? Now, if I wanted to find the distance between this point and this point, all I have to do is count along the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sure enough, and it would be the difference between the x's, wouldn't it? The distance between the two zeros is just 0, so filling it in here, it would be 10 minus 0, which is 10 squared, right? Plus this would just be 0 because there's no difference along the y's, right? So you get 10 squared, which is 100. The square root of 100 is 10. The distance, therefore, is 10. Or you just count the number of units, right? And then, there you go. Same thing would happen if we do the y's. I'll let you go ahead and do that on your own. But here's the question, right? What about the distance between this point and this point? Notice that it's on the slant here, or the diagonal. Let me just draw that in here real quick. Okay, so what is the distance between that point and that point? I can't just count the number of units over because it's increasing in size. So that's when this distance formula becomes very important. Now, by the way, I'm just going to complete this triangle and say that we know that that distance was 10. We already knew that that distance was 10 units, right? And now we're trying to find the distance of that one. So according to this, the distance is going to be equal to the square root of, let's just take the distance between two of the x's. So the x values here would be what, 10 and 0. So let's just go 10 minus 0. Now notice it says x2 and x1. It really doesn't make any difference which one's the x2 and the x1 is. As long as you've got the distance, the difference between the two x's, you're going to be okay. And that's going to give me, and then quantity squared. Now let's find the distance difference between the two y values, and it's 0 minus 10. I'm just trying to keep them in the same order. So 0 minus 10. Again, quantity squared. Now let's just follow PEMDAS really closely. Now, one thing to remember is that the radical sign is actually a grouping symbol itself. So it's like a larger grouping symbol. And in PEMDAS, you're always supposed to go to the innermost grouping symbols first and work your way outward, right? So the innermost grouping symbol is 10 minus 0. That's just going to give me 10. And then again, quantity squared. Innermost grouping symbol 0 minus 10, or negative 10. Again, quantity squared. Again, according to PEMDAS, you're supposed to move to the exponents now. So we've got 10 squared is equal to 100. Negative 10 squared is also equal to 100. Now I can go to the additions and subtractions. Here we have an addition. Square root of 200, and we know from our radicals that we could probably either do one of two things. We could just go ahead and put this into our calculators and see what that actual distance is, right? Or we can just change it to the radical form, right? And let's just see. I can change 200. If I were to reduce this, it would be like the square root of 100 times the square root of 2. Square root of 100 is 10. 2 stays the way it is. So that distance then would be 10 radical 2. Okay, so we knew that this side of the triangle is positive 10. This side of the triangle is positive 10. And this side of the triangle, this long side, is 10 radical 2, or whatever that happens to be. Now, I'm just going to do real quickly. I know that the square root of 2 is 1.414. Times that by 10. So it's approximately, what, 14.14 units. Okay? So again, use this distance formula. It's very, very useful. And remember that it's just a difference. Usually you use it when it's something on a slant. Horizontals and verticals, easy. Just count them over, although you can use this formula. But that's when it's really useful, when it's on the diagonal like that. Okay, hope that was helpful.